Yesterday, we graphed it all out. We identify that this is, how many function? One function. How many pieces in the equation? Three. But when we graphed it out, they happen to overlap and we just saw two. Okay, but in the equation, it said so 3. And we introduce a new notation here. What's a new notation here for domain and range? Up until this point, we have been saying the domain is all real, the range is all real because we have only been studying lines. And yesterday we said, okay, now we can say the domain when it's all real, we can technically say from negative infinity to infinity. And then the range is no longer all reals. Can you guys see that? It starts at somewhere and then it stops and then it continues. Now in the notation, we use this U right here to say that it's going to pick up where it's supposed to. So in the notation, we use quantity, okay, parentheses in this case, if it's not inclusive. What do I mean by not inclusive? Parentheses for not inclusive. What do I mean? Open circle or closed circle? Open, right? And then we use bracket right here to say that these are inclusive. Closed or open? Closed. So two different interval notations. Yesterday, before you were gone, I asked you to find f of 2. So let's verify that really quickly. F of 2, class, the 2 value right here, is that an x value or y value? It's an x value, okay? You have an x value for that. And yesterday, we said, okay, look at the graph. When x is 2, 1 and 2, what do we get? 5, okay? Now, we can also use your equation. Out of the three pieces, which one of those pieces contains an x value of 2? Piece number 1, piece number 2, piece number 3. Piece number 1, what must x be? Less than what? So it's 2 in that domain. No, it's less than. Piece number 2, what is the x value? From where to where? Negative 2 to 6. Is 2 in that domain? Yeah. Yes. So algebraically, this is what you need to do. To find f of 2 algebraically, we pick the correct piece. What piece again? Second one. So we go, okay, negative 1/2 times what? Negative 1/2 times 2 plus 6. Negative 1/2 times 2 is negative 1 plus 6 is 5. In this case, our graph matches with our algebraic work. Sometimes the graphing is not as exact, so you might want to check it with algebraic work. Bless you. F of 8. Is 8 an x value or y value? X value. Now, out of the three pieces, which one contains 8 in its x value domain? The third one. Oh, that one's easy. Everything on the third piece is always what? 3. So guess what? F of 8 is just 3. Okay. You can just box up the 3. I'm just writing it all so we know. Raise it up. Yes. Okay. Or pinch it in, I should say. How about the last one? What are we looking for? Are we looking for x or y? It says find x when y is what? Negative 9. All right. Out of those three pieces, which one has a y value of negative 9? The blue piece, the green piece, or the red piece? The first, right? When y is negative 9, what is x? When y is negative 9, what's x? Yeah. Will you agree that this is negative 9 right here? Negative 9. Is that what it says right there? I want to make sure. Is that what? Yep. When y is negative 9. X is what? Negative 1, negative 2, negative 3, negative 4, and negative 5. So we can count. Okay. So it's the first piece. Also, You can check it algebraically. We counted it and we knew it was -9. Would you agree that I can take the first piece because that's the blue graph? True or false? Okay. Set y equal to -9 and solve for what? Solve for x. We're going to move the -1 over. If I subtract -1 from both sides, what would I have now on the left side? -10 equals 2x. Can you see, because we graphed it so beautifully, it's the same answer. Okay. So if you are a perfect grapher, you can look at your graph. If you're not so sure, would you agree you can always do it algebraically? Okay. All right, go ahead and copy this down as we... Here are the guidelines, the steps to graph piecewise functions. You have most of these already, you just have some blank spaces. So these are the guidelines or instructions of what we should do when we are graphing piecewise functions. Number 1, Brandon, can you help me read number 1, please?
Determine how many pieces that are based on the numbered equation.
Yeah, if there are 3 pieces in the equation, you should have 3 pieces graphed out. Number 2, Malin H.
Determine what shape each piece is, a segment or array going which direction.
Oh yeah, how do we know if your piece is a ray versus a segment? What do you need to know that it's a segment?
2 points.
Yeah, it starts here and ends here, right? If you see something that says x is greater than only or x is less than or equal to, that will constitute a array because it's only one. Okay. Number 3, Mariana, can you help me read 3, please?
Determine the x values of the endpoints of each piece based on the domains.
Correct.
Whether they are exclusive or inclusive within our closed circle.
Right. We use a bracket. A bracket represents inclusive or not inclusive. A bracket. Inclusive. A bracket would mean inclusive. That would be a closed circle. Okay. Next one. Bless you. Elena, number 4, please.
Graph each equation over its specific domain.
Perfect. Number 5, Alan. Okay. Double checked that what you have graphed is a function. And last one, Alyssa. Perfect. We have one more example, and then I'm going to give you some time to do the check for use. Okay. Example dos. How many pieces, Sophia C, how many pieces is this? 2. Okay. Guys, can you guys tell me what these things are here for? What are those? Yeah, it tells you the value of x, like restriction of x. Would you guys agree? So they're not pieces, they're part of the pieces. So piece number 1, I'll do it in green, okay? And then piece number 2, I'll do it in blue. All right, so we'll make a table for piece 1, x and y. Thank you. And then I'll make a table for piece 2. Okay, now each piece we should use at least 3 points, because the more points we have, the better your line. All right, piece 1 in the green. What should we start with? -6, and we know that will give us an open circle or close. Open, because it's not an equal to. We will start with -6, and we're going to say, okay, this is going to be an open circle right here. All right, give me 2 more values. That's less than -6. -10, beautiful. What else? -8. Okay, so now write -8 first and then -10. All right, let's plug it in. Ready? 2 times -6 plus 7 is what, y'all? 5? -5. Okay. Go ahead and find the output for -8 and -10. When x is -8, please plug it in. Let me know. Sophia N, let me know what the output is when x is -8. And then -10, go ahead and plug that in. Brian, whenever you're ready, plug in -10 and give me the output. -9, do you guys confirm that for me? Okay, so -9 here for -8. And then Brian, whenever you're ready, hon. Once you have all 3, go ahead and plot the dots and graph your ray or segment. -13, confirm? Okay. Is this a ray or a segment? Is it a segment or ray? It's a ray. Would you agree that it only has 1 starting point? All right, plot your dots. -6, go down to -5. If you need to, can you extend 3 more tick marks and make it -13? Yes, always. So -6, 2, 4, 6, 2, 4, 5. Ooh, open circle, right, y'all? Which I made it wrong, and it's not. I need to erase. 2, 4, 6, 2, 4, 5, open circle. -8 was -9. And then I'm going to make 1, 2, 3 more tick marks. Use your straight edge, guys. Okay. There is your first ray. Now, piece número 2. What do we start with? Yeah, -6 as well. Except that you're going to have an open or closed circle. Close, you're right. -6. We're going to plug it in. -1/2 times -6 minus 4. What is that output? -1/2 times a -6, that's a +3? Yes or no? +3 minus 4 is going to be a -1. Okay. All right, give me 2 more inputs that will work nicely with your fraction of a half, right? You don't want some funky ones. Yeah, -4, -2. Can I pick 0? Yeah, we love 0. I love 0. How come? I don't have to do a lot of work. All right, plug it in. Let me know the outputs when you're ready, okay? When x is -4, and by the way, you don't have to pick these values. I just use this one. Why? Because he told me so. You pick whatever you like. Okay, Kyler, give me the output for -4, okay? -2. And then give me the output, Megan, give me the output for 0. Okay, let's plot the dots. At -6, we know that it's closed or open, y'all? Closed. All right, -6, go up 1, close dot. I'm sorry, go down 1, close dot. -4 is now 2, 4, and then -2. 0, we got to go down to 4. All right. Ray or segment, What is it? Isn't it an array? It only has one starting point? Right? It's an array. All right. We got to answer all of the parts. Question number 1. Is it a function? How do we know it's a function? Take your pencil and do what? Okay, do a vertical line test. At some point, any point, does it ever intersect more than twice? I mean, more than once, I should say. Oh, but this, what happened? It's intersecting, it looks like twice, but this does not exist. It's not even there. So it's still going to intersect once. So is this a function?
Yes.
Yep, totally. What do we do to check for one-to-oneness? Horizontal. Take your pencil. Put it horizontally. Go up and down and tell me, is it one-to-one? No, because would you agree that this line, this blue line, technically goes down forever?
Yes.
And it goes down forever. At some point, would you agree that it will totally intersect horizontal line test twice? So is it one-to-one? No, it's not a one-to-one. Okay. Is it continuous? No, you have to lift up your pencil. What is the domain? All real numbers. How do you know? Yeah, you're given all reals. And also look at the graph. This arrow means, would you agree, it's going to go left forever? I'm going to start from negative infinity. I'm going to keep going, keep going, keep going. Although there is a break right here at the open circle, but right above it is a close one. It fills it up. Would you agree that this blue line goes on forever? So that is a domain of what? All reals. How do you write it as an interval notation? Negative infinity all the way to infinity. The range is something a little bit newer for us in terms of writing interval. The range is asking for all values of what? Y. What do the arrows mean? Starting where? Negative infinity. All right, I'm going to keep on going up. Do I go up forever? No. What's the highest y that we have? Negative 1. So would you agree the range is all y values less than or equal to what? Negative 1. How do you write that as an interval notation? Negative infinity, the smaller the number must always go first in interval notation. Go all the way to what? Negative 1. Parentheses or bracket? Bracket, because it is inclusive. Find f of negative 8. Is negative 8 an x value or a y value? X value. Now we have to go look at all the pieces. Out of those two pieces, which one contains a negative 8 for your domain? The first one. Whoa, did you guys do that already? Yes or no? We found it. When x is negative 8 in the first piece, what's the output? That's right. Sometimes you just got lucky and you already did that. Oh, it says negative 9. How about find f of 5? Which piece contains the domain of 5? The second one. Did we find that already? No, so that means we have to find it. Ready? F of 5. Plug in 5. Every time you see a what? An x. So plug in 5. And then minus 4. Half times 5 is really 5 over 2. Negative 5 over 2. Minus 4. True or false? Now what are we going to do? Yeah, make 4 into common fractions. Or would you agree that negative 5 over 2 is like negative 2 and a what? Negative 2.5? Yes or no? Negative 2.5, negative 2.5. Take away 4 is negative what? Negative 6.5 or negative 6.5. Okay. In this particular case, we can write decimals or fractions because they round perfectly. Okay. This one, what are we going to try to find? Find x or y? Find x. When what? When y is -4. Y'all, this is the same thing as when saying this, okay? F of x is the same thing as that. Now, I'm going to pinch it in so we can look at the graph. Out of these two pieces here, look at the graph. Which one? The second one. And do we know the answer already? Yes. Now, in the case that we don't know the answer, you would have to work it out algebraically. Would you guys agree? Okay, so what's the answer right away? 0. X is 0. And box that up. I'm going to pinch it in so you can write that in. Now, in your team, why don't you guys take the first few minutes to make tables for your check for understanding, which is your example 3 there. I'll give you guys, let's start with 4 minutes head start. So everybody, do a 4-minute head start on check for you. Work together. Okay, so there's 2 pieces, right?
We can pick whatever number
that fits in that restriction. So it's not a 3 choice, it has to fit in the restriction.
and then the end one just be 0. So and then you go from there to that. Or 1, 2, 3. Well, it has to be less than or wait, so it'd be 2 times -3 equals that. But can it just like that? It can't be 0. It can't be 0. So it has to be negative. It can be x because it can't be negative. This one it could have been 0. Well, yeah, you're right. I have a question.
Yeah, go ahead and ask. I'm just gonna make the table.
Well, so in number 2,
Oh, yes.
we used -6 for the first one, even though it's just less than and not equal to.
Right. That's when we have an open circle to represent that not there.
So, but if it's a closed circle, we can't do that.
So this one is closed.
But we do it on that one.
We always start at that value. Always.
So this is the second piece. One of my points be 0.
It must be 0 and it must be -3. And then the middle point is your choice. Okay, this is a tricky piece right here, y'all. In the middle, can you see that there's a second piece in the middle? What the earth is that? Guys, the second piece, it says y is always what? What's y? 0. Y is always -3 at only how many x location? 1, class. You were only given 1 x location of what? Of 0. So technically, how did you graph that out? It's just a point. It's just a dot. It's not a ray. It's not a segment. It's just a dot. That does not have multiple x values. Okay? So the second one is just a dot. The range, okay, so the range is all values of y. Do you agree? Okay, so think about down here. Okay. always start well, you always start left. Are there any y values down here eventually? Yes, these arrows will start. When we start at a negative what? So where does it stop? 5, 3, y value of what? Yeah. You're right. And then it should, so that's what we write for y. Now, in implementation, we have to write a smaller number first. Make it all the way up. Make it one Okay. I'm just gonna verify whether your chart's right, okay? Okay, piece number 1. Ready? Team Olivia. Is that a segment or array?
Array.
Class, piece number 1, segment array. A segment. Guys, how do you know? It has a starting point of what? -3. It has an ending location of what? 0. Although, at 0, open circle or close? Open, okay? At 0, it has an open circle. At -3, open circle or close? Close. Now, in the middle is when you have a choice. Give me a choice in the middle. -2, -1. Are those values okay? Yeah, it's really a person, no. Okay, I'm sorry, Chizuki, you had hands up.
I was gonna say 1 x. Why do you put 0 as an x? 0 is not less than 0.
You're right. That's why it's an open circle. An open circle means it's not even there, but it's super close. Would you agree that I can pick something that's less than 0 as a -0.00001? Yep. But I can't really graph. You know what I mean? That's why. Good question. All right, let's plug it in. At -3, what is your output? Hannah, what's your output for -3, hon? When x is -3, what's the output for the first piece?
The first one?
Uh-huh.
Oh, I got -1.
Yes, you are right. Okay. At -2, Slater, what is, since the class picked -2, Slater, what is the output? First piece, okay? 1. Thank you. At 0, what is the output? So class, at 0, what's the output? 5. And we know it's an open circle. All right, let me go and plot that guy out. -3 is going to be -1, closed circle, okay? We have -2, +1, -2, +1, and then at 0, we said open circle at 5. True or false? 2, yep. If you missed your dot, there you go. That's segment numero 1. Now, number 2 is not a segment, is not a line. What is it? It's just a point. When x is 0, y is -3. Make a dot. Now, piece number 3, you will start with what value? 0. And you would know that's going to be an open what? Open circle. Then we're going to pick 2 more values that's bigger than 0. So what value did you guys pick that's bigger than 0?
1.
Yeah, why not? 1 and 2 sounds gorgeous. Output is 0. The next one's -5 and -10. Yes or no? All right, maybe. Hope so, right? Okay, here we go. Open circle at 0, 0. Yes or no?
Yes.
Then we're going to go 1 is now down 5, 2, 4, 5. And then 2 is now negative 10. Super close to that green dot. Ray or segment? Ray, okay. All right, let's answer all the components. Is this a function? Yes, it's a function. Okay. Now, this is the part where it's a new concept to us, the one-to-oneness. Is this a one-to-one function? No, because would you agree that right here intersects that green dot and the red line? And over here as well, the purple and the red. So it is not a one-to-one when you do your horizontal line test. Is it continuous? No. What is the domain? I'm gonna make it bigger so we can see. Domain is talking about all values of what? X. Do we start with negative infinity? No. But we will start where? Negative 3. Inclusive or not inclusive? Inclusive. Do we have a negative 2? A negative 1? A 0? A 1, 2, 3, 4, 5, 6, 7, positive infinity? Yes, how do we write that? X is bigger than or equal to what? Negative 3. Okay. So for